The following is Fall 2011 Math 115 Test 3, number 13, 14, and 15. Number 13, we have this polynomial divided by a monomial, and because it is only a monomial, what I will do, I will separate them. Each term on the numerator divided by the same denominator. My plan is, after I'm done with this step here, I will simplify each rational expression we have. Now, for example, the first term here, the number will become 2. The x, only one x left on the top, and the y cancel out, so we have only 2x left, minus the second term, 4 and 6 reduce becomes 2 over 3, the x cancel, and for the y, only one y left at the bottom. Okay, last term, the 6th day, the x, one of the x cancel, so I have one x left at the bottom, and then I have y squared at the bottom. Now because we have nothing on the top, then we will put 1. Well, that's because earlier we divide the top by x, right? When you divide the x by x, we have 1, not 0. Okay, a big warning. Maybe I put a mark there. This is not 0. Also, the whole thing here, not 6xy squared, as if they were on the denominator, on the numerator. No, it is on the denominator, and because it's on the denominator, you need to put 1 over. That's for number 13. Number 14, factorize this. Okay, you can factorize this the way we did it before, but I want you to notice that the first term here is a perfect square, and the last term also a perfect square. Now let's try to see if the perfect square work here. This is 4x, this is the 3y, right? If I multiply, I get 12xy. If I do the double down, I get 24xy. Now it doesn't match with 40xy, so not this one, not this one. No. Then because of that, I will do it another way. Let me grab another paper. I will do the following: either 16x and x, or 8x and 2x, or 4x and 4x. Now, as for the sign, it will be in both minus, right? Because the same sign, both of them minus. And then for the 9, it's either 1, 9, 9, 1, or 3, 3, right? 1, 9, 9, 1, 3, 3, 1, 9, hold on, is it the one? Yeah, this will give me negative 36 minus 4, that's negative 40, right? Now, of course, you may say, Thomas, you see that 9, 1 also work? Well, that's because of the symmetry of 4x minus 1, 4x minus 9 is the same too if you write it the other way around. So seems like we already know the answer. This will be 1, 9 here, or if you want 9, 1 also okay. And because I have the y and y squared there, I will insert y here. I will insert y here. Okay, now you see that if you FOIL this, you should get that answer. Okay, now if I go back, you will see that, let me cross this out, doesn't work. This is equals to this one, 4x minus y, 4x minus 9y. 4x minus y, 4x minus 9y. Okay, that's for number 14. Number 15, factor completely. This seems to be very nasty, but for that reason, then we may suspect that we have a common factor. For example, the 45, 78, and 24, all of them are multiple of 3, right? Okay, how do I know that they are multiple of 3? Well, because 45 is multiple of 3, 78, 7 plus 8 is 15, it's multiple of 3, right? So 78 is multiple of 3, 24 also multiple of 3. So I will take 3 out, and as for the x, I will take x out, right? Because that's the lowest exponent, that's the one they have in common, and I will take y out also. Now this way, then I will get 9x squared plus 78 divided by 3, that will be what's that, 26, plus 8y squared. Okay, now from here I will factorize the grouping further. Let's see if I factorize the grouping further. That's a prototype case, right? So it's either 9x and x, or 3x 3x. The sign will both be positive, and for the 8 is 1 8 8 1 2 4 4 2. Okay, 9 1 8 8 1 2 4 4 2. Do we get anything? The first one doesn't work, the second one doesn't work, third one doesn't work, this one doesn't work, this one doesn't work, right? Because that will give you 24 plus 3. This one, or the symmetry, doesn't work. This will be 12 plus 6, 18, doesn't work, doesn't work, nothing works. So the final answer will be just this one. We can't go further. Okay. No, but we can't also say, we can't say, let me write a little note, this is can't say prime or non-factorable. Why? Because we did factorize something. So the expression here is factorable. It's only this part here not factorable further. Okay. But in general, in total, this is not say you can't say that this is a prime, or you can't say this is non-factorable. This is for 2011 Math 115 Test 3, number 13, 14, and 15.